cheesy introduction for today? Oh man, this is already sounding cheesy. So that's already on. Oh well. So we've already seen that the integral, the definite integral, has given us the area under the curve. We're going to do the same thing today, except our questions are going to be just worded slightly different. They're going to say, what if our question started off by saying, what is the area under the curve, or what is the area between the curve and the x-axis? Now, for a lot of times, that's exactly the same as what we were doing the other day, but sometimes it's going to be different because we saw the other day, especially with that sine one where things canceled out and the area ended up being 0 because we had some area above and some area below. So if the question said, what's the area between the curve and the x-axis, we would have to do something different in that case rather than just finding the definite integral between two values. But if we have a function that's positive and continuous, then the area between the curve and the x-axis is just what we've been doing before, which is the definite integral. So here is our example, and we're going to draw a little picture of a graph off to the side. So 2x minus 1, that has a y-intercept of minus 1, a slope of 2, and it looks like this. If we were trying to find the area between x equals 1 and x equals 5, that would be this part. So I'm going to color it in. Ooh, love coloring with crayon. There we go, perfect. So we're looking for that area. Oops, I colored too much, didn't I? Perfect. Now you just have to imagine everything in there. Okay, I'll draw it in. It's going to bug you, isn't it? There we go. It's going to bug me now. Crayon again. Oh, yes. Okay. I could color all day. So in this example, we can see that where we're trying to find the area, our curve is completely positive all the way through. So we don't have to worry about anything. This is just going to be the integral from 1 to 5 of 2x minus 1. So calculating that, is just a matter of finding our integral, which will be x squared minus x, plugging that in. So when we plug in 5, we're going to get 25 minus 5. When we plug in 1, we're going to get 1 minus 1. And we get 20. So that was relatively straightforward because the whole thing was positive. So anytime that your graph begins and everything is positive to begin with, when you want to find the area between the curve and the x-axis, it's going to be just as straightforward as finding the definite integral. So one of the skills that you need to have is to be able to draw a quick sketch of what you're finding the area between. So for this one, 15 minus 2x squared is your equation. You might think of that like this to help you with your transformations or to help you remember things about parabolas. So if you like to think about transformations, that negative 2 is going to flip it down and stretch it vertically. And then the plus 15 is going to move it up 15. Either way, our vertex is going to be up here at 0, 15, and our parabola is going to be opening down. Now, a couple of things about it opening down. maybe you remember from previous years with that -2 that you can go over 1 and down 2. And then do you remember how much you'd have to go over and down the next time? Down 6, because it goes by odd numbers for a parabola, 1, 3, 5, 7. And since it's a 2 in front, those would be doubled. So it goes 2, 6, 10, 14. So if I go down 6 again, now I wanted to go at least that far because I want to find the area between -2 and 2. And so now I know that the part that I'm finding the area between is completely positive. So this part that I can shade right here is completely positive. So in order to find that area, again, we can just do the definite integral. And plug our values in. Distributing that negative, first of all, I'm going to put together my terms that are easy to add. So 30 plus 30 is going to be 60. Negative 16 over 3 and another negative 16 over 3 is going to give us negative 32 over 3. So if we wanted to get a common denominator here of 3, we'd have 180 over 3 minus 32, which gives us 148 over 3, which you could leave like that, or if you wanted to change it to a decimal, what would that be? 49.3 repeated, something like that. Quick check. Good, perfect. So again, since the entire curve was positive to begin with, this is relatively straightforward. So here's one, again, that's going to be all positive. I want you to draw the sketch and then calculate the area. I'll put the answer up in a bit. All right, let's see how you did with your graph. There's your cos graph, shifted up 1 unit. So it'll reach a maximum here at 2. Your sinusoidal axis, or the middle of your graph, is at y equals 1. And the shaded part is right there between 0 and pi. And when you integrate, and I got a little crazy with the crayon here, sorry about that. There we go. I wonder who thought I should invent a smartboard pen that writes like a crayon. Didn't know they would give me so much joy in my life. It's a little bit thicker? What do you mean? Like here? Well, that's because I colored over it many times. Like I got my crayon, just like regular crayons, right? You color a little bit, then you color over top, it gets darker, but it never really fills in completely, see? And then you get these spots that are way too dark. So now, they would invent them that also smell like crayon, or that would be even better. Like those markers that used to smell, what were they called? they called? I can't remember. Right? And then kids would come home and their nose would all be like the watermelon one. All right. So that is the last example that, oh, here we go. Here we go. Now we're going to look at what happens if part of it was negative. Because now if you're finding the area, we found out the other day that our definite integral makes all areas underneath the curve negative. So if the whole function was negative and you're finding the area, well, if to actually say the area is a positive number, you'll find your definite integral and then just take the absolute value of it. That'll just change it to a positive number. So here's one example where that happens. Here's our 2x minus 1 function that we drew before. But now if we want to find the area between -4 and -1, this entire area is below. Should have used red. There we go, kind of. There we go. Pretty. So there's our sketch. Now the entire curve is negative. So if we were to find our integral between -4 and -1 of 2x minus 1, we're going to find out, again, we already figured out that x squared minus x, plugging in these values in, you're going to get 1 plus 1, 16 plus 4, 2 minus 20 gives you -18. So the idea being that if you've done a sketch, you know that that's going to be your result. Okay? And if the question had asked to evaluate this definite integral, then your answer would be -18 and you would leave it that way. But since the question said find the area enclosed, it's asking for an area. An area is a positive value. And so what you can do after the fact, if you'd like, you could say, well, since I know this is negative, I can put absolute value bars around everything all the way through. And then my final answer is going to equal +18 because an area is going to be a positive number. What's that? It could have units if this was some sort of equation that was measuring something, then it could have units. But for this example that we're looking at, there was no units given. So we've looked at what happens if it's positive, what happens if it's negative. We haven't looked at what happens if it's both positive and negative over an interval. And the question says, find the area between the curve and the x-axis. Well, what you're going to have to do then, right? Here's the picture of our graph, and you want to find the area between this point and 0. There's going to be this section that's negative, this section that's positive, and if you just do the definite integral between 0 and whatever that number is, it's going to subtract things out and give you a number that's not the actual area. So what you're going to have to do is you're going to have to find that point, that x-intercept. And then you're going to find the red area, which will be negative, and do the absolute value to make it positive. And then you're going to have to find the blue area, which will already be positive. And once you've got both positive values, add them together to get your final area together. So we're going to find all of our x-intercept, separate those integrals into those parts, find them separately, make all of your areas positive, and then add them up. So here's our example, x squared plus 4x hope you realize this is a parabola that's going up. And if you were thinking about this parabola and you were trying to graph a sketch, it's not in the vertex form, so we can't see the vertex easily. I guess you could use calculus and take the derivative and find the vertex. It's not too bad to do that. Okay? You could also factor this. Since we're going to need x-intercepts anyways, we set y equal to 0, factor out the common factor of x, and we find out that at x equals 0 and x equals -4, those are our two x-intercepts. If you know the x-intercepts of a parabola, you also know the x-coordinate of the vertex. Can you see that the x-coordinate of the vertex is going to be at -2? Okay? And you could have solved that with calculus quite easily as well. And if we plug in -2, we're going to get -4. And there's our vertex for our parabola. Our parabola is opening up, so we can draw a quick little sketch of it here. Now, we want to find the area between -2 and 2. So if I draw lines at -2 and at 2 and color these in, I'll have part of this, which I've colored here in green. This area, when you do the definite integral, will be positive. But this area, which I'll color in this color, kind of orangey mustardy, that mustard part will be negative. And so when we figure this out, we'll have to do things separately. So we're going to find the integral from -2 to 0, and then the integral from 0 to 2. So when we write this out, we're going to find the integral from -2 to 0 of x squared plus 4x. And we're going to add that to the integral from 0 to 2 of x squared plus 4x. And we know that the -2 to 0 one will be negative, so if you'd like, you can add the absolute value bars there already to make it positive. If you have no idea which one's negative and which one's positive, you could technically put absolute value bars around everything, because it wouldn't make a difference. But this seems like you're feeling a little bit more sophisticated, like I already know that that one's going to be negative. So, right, maybe you're trying to impress your math teacher a little bit. So now when we figure this out, we're going to have x cubed over 3 plus 4x squared over 2. Keep that in my absolute value bars. And I don't need to put absolute value bars on the other one. And once you find the integral of one, the other one's going to be exactly the same. And when we plug things in here, plugging in 0 is going to be 0 plus 0 minus, plugging in -2, -8 over 3 plus 8. And then we're going to add. And the nice thing about this is you've probably already figured out the values. So plugging in 2 is going to be 8 over 3 plus 8 minus 0 plus 0. Well, it won't be a 0 because both of them are going to be positive areas in the end, and you're going to add them together. If you didn't have that, then a lot more things would cancel out. So just putting things together, if 8 is 24 over 3, this is going to be 16 over 3 with the negative. But that's still in my absolute value bars on the left. So it is right that we figured out that that section was negative. I'll simplify it first there. And then on the other side, we're going to have 8 over 3 plus 24 over 3, which will be 32 over 3. This absolute value bars will make this positive. 16 over 3 plus 32 over 3 will give us 48 over 3, which is 16. So we get an area of 16 in the end. Sometimes you'll have more than one x-intercept in the place that you're trying to find. So I'd like you to try this one on your own. Sketch the graph as best as you can. And I'll put up an answer in a bit. All right, let's see how you did with your graphing. First of all, you can factor this function completely to find out that your x-intercepts are 0, 2, and 1. And then if you remember a few things about graphing, because you just want to make a quick sketch, because it's an x cubed graph and it's a positive x cubed graph, it will act like a line starting at negative infinity and rising from left to right, just like a line with a positive slope rises from left to right. So with those, you can draw a quick sketch. Calculus could tell you where those maxes and mins are, but for this question, you don't need to know where they are. You just need to know that the first little bump is going to have a positive area. The second part between 1 and 2 is going to have a negative area. And the third part is going to have a positive area again. So notice what I did here so I didn't have to write so much, because it would get a little bit annoying to write x cubed minus 3x squared plus 2x 3 different times. So since that's equal to y, I just wrote y instead. And I split up my integral from 0 to 1, 1 to 2, and then 2 to 3. And I put green absolute value bars around that middle part because I knew from my graph that that was negative. Okay. So again, plugging in values, you'll notice that a lot of the numbers end up being the same. In fact, when I plug in 1 in the first one, I'm going to get 1/4 minus 1 plus 1, and plugging in 0, I get 0. This first set of brackets is 1/4. Can you see that you get to use that again right there? Because you have to plug in 1 for the second part. So you do have some shortcuts here that you recognize things. And same thing with the 2. Well, 16 over 4 minus 8 minus 4 ends up being 0, so when I had to figure it out here again, I could do it quicker. Not sure what's happening in the hallway right now. I guess some people can't handle the excitement of shortened periods in the afternoon. So getting a common denominator and working through all of that, you'll get 9 over 4. This big bracket? Yeah, I have no idea. That's a good question. It's just there. Yeah. It adds artistic. Wow. Okay. So we have about 15 minutes left. Try some questions there at the end. I don't think those ones that I showed you there are actually yours. Here they are. Those are the questions you can try.